Okay, so this program will be right at the beginning of the lecture video. And this is the general structure you're going to use for the Moonglow program in Lab 1. So you should either have this copied into your notes, or you'll want to look at the video tonight because this will be very valuable to you over the next week. Okay, let's make sure it works. Actually, I'm being a little arrogant here. I'm assuming it's going to work. So let's actually try to. Now, for those of you who don't know, in Unix, if you hit the tab button after some number of characters, you get autocomplete. Whoops, it should have gotten autocomplete. Huh, it's not giving me autocomplete.
It doesn't have a of, maybe?
Yes, you're right. Thank you. Now I hit auto. There we go. So it auto-completed to what it was to the next ambiguity. And that ambiguity is there's an executable named sum of integers, and there's a .cpp file. But if you hit tab after a couple characters, it will give you a string up to whatever the next unambiguous I guess fragment is. Very handy. Okay, so it compiled, and let's run it. 1030 Brad 40, and the sum is not what I expect. So after me saying, hey, that works, we can see that apparently I mucked it up. So we're going to put some print statements in. So this is what you're also going to be doing in lab tomorrow. So let's try to figure out what's gone wrong. So for there, otherwise, we're going to be in bad input. Okay. Really surprised that that did not work. Do 1030 Brad 40. So we have I equals 10, I equals 30, bad input equals Brad, I equals 40. So this is looking pretty good. Sum equals 80. Did I? What? Hello? Okay. Let's take those cout statements out. But at least you can see what you should do for debugging. Notice how in each of the if statements I put debugging statements. I'll compile again. Run it. Whoops. Run it. Well, I have zero idea as to why it was failing. Because, wow. That's bizarre. Thank you. I must not have saved it. That would do the trick. Thank you. Yep, I did not save it. Okay, so I'm going to take the debugging statements out of there. Any questions about that? So that shows you how to detect bad input using the if statement, and you recover with the clear and the read. Now, when you clear a printer, it doesn't really matter generally whether you pull the paper out first and then hit the clear button, or you hit the clear button and pull the paper out. So let's see if that order matters here. So instead of clearing first, I'm going to clear after I try to read the bad input. Okay? Okay. If you're wondering what the exclamation mark G is, that gets the last command that started with a G, which, come on. Well, my computer is really being 3-letter word, 7-letter word today. Okay. So it found it with G+, but it couldn't find it with G. Ah, very good. Thank you. You're absolutely right. I typed a G here. So then it said history. So if we look at our history, yep. So you can type history, and that's what it's looking through when you hit the G. So when I entered the G initially in history, there was now a G. So now when I said G, it found the command at 517. Actually, it found it at 512, but you get the general idea. Okay, so let's run some integers again. 1030 Brad 40. Hit Control D. Hit Control D. Something's wrong. How do we get out of here? Because something's really wrong. It's in an infinite loop is what's wrong. It's ignoring me, by the way. How do I get out? Control C. Okay, so order does matter. You have to put clear first, and then you have to put the read of the bad input. And the reason that the order is important is that the clear says to C++ that the stream is no longer jammed. Here, when you try to do the read, C++ says, oh, it's jammed, and it fails with the CN. So it doesn't actually read the input because it's still jammed. Then it does the clear. So it comes back up to the while statement, and it now rereads Brad, which is not an integer. So it comes down to here, again, tries to read Brad into bad input and fails because it's jammed. It clears CN, comes back up here, tries to read Brad into I, fails yet again. So the reason that Control D failed over here was it was in an infinite loop. It was stuck on Brad, and it was never getting to my end of file character. Okay, so just to be clear, order matters. And that is the order. Clear first, then you read into bad input. Questions? Okay. Now, let's look. So the second thing I said we're going to do is we're going to look at the perils of the EOF function. Okay? Let's write another program. And I'm going to call it echo input.cpp. So all I'm going to do is echo the input. So I'm going to say while, whoops, I need a string S. And I'm going to say while not cin.eof. Cin into S, Cout S. Very simple program. So while I haven't reached the end of file, I read a string, I print the string. Maybe if I said endl, it would compile. We good with that? It's just reading input and echoing it out. Okay, I compile it. I run it. Anyone see a problem?
That's the new line.
No, it's not. The problem is not with the new line. That was fine.
Did we forget to return 0 or?
Nope.
There's the duplicate 50.
There's a duplicated 50. Do you see two 50s in the input? No. You see 150 in the input. But there's two 50s at the end. Let's do it again. This time, Brad, Smiley, Fred. There's another Fred at the end. Fred got printed twice. There's a problem. And the problem is that EOF is reactive, not proactive. What does that mean when I say it's reactive, not proactive? What it means is that it cannot detect the end of file until after the input has been exhausted and an attempt has been made to read it. So let's look at what's going on. Get another page. So our input the first time was 30, 40, 50. So think of C++ as having a little cursor or caret that indicates where it is in the input. So at the beginning, the caret is before the 30. And when it says, have I reached EOF? Well, the caret, and then actually, there is something more. There's an EOF character right here at the end of the input. Okay? So it checks, have I read the EOF character? No, I haven't. So it goes in, reads 30 into S, prints it out, and it moves the caret to right here before the 40. It comes back to the top. It asks, have I read the EOF character? The answer is no. It reads 40, prints 40, and moves the character, or the cursor, in front of 50. Comes back up. Have I read the EOF character? No. I read 50. Print it out. Caret moves to here. And here's the important thing. Have I read the EOF character yet? No. So it returns false, saying I'm not at EOF. So I come into the loop. I try to read something into S. But instead, it reads the EOF character. So at this point, it reads the EOF character. Cin fails. What happens when Cin fails?
Doesn't overwrite.
Doesn't overwrite. What happens is whatever was there before is still there. So whatever was the last piece of input in the file is what ends up in S, and we print it a second time. Okay? So that's what we mean by EOF is reactive, because it only returns true after you attempt it to read past the end of file. It's not proactive. It doesn't peek ahead. Okay, what you really would like is for it, when it's right here, to peek ahead and say, is the next item the EOF character, but it doesn't. Okay? And that's going to cause many of you grief because many of you like to write this code and it doesn't work. Okay? So if you, in general, what we prefer when you are reading input is that you simply move the CN up to there, like that. And now it will work perfectly. Okay, so if I enter 10, 30, 50, there's no 50 that gets printed out. If I enter Brad nails Fred, again, Fred doesn't print out a second time. Okay, now in that Moonglow example, I had to go to a while true because I couldn't be sure that the input was valid. But anytime I'm just in effect reading something and I'm pretty sure it's valid, I'm just going to do something with it like echo it, just use this idiom. It will save you lots of heartache. Okay? Questions about EOF? Okay. Now, CN can also read characters one at a time. So this is the next topic, char input. Okay, so sometimes you want to read a character at a time. Let's do that. And I am going to echo, all I'm going to do is echo in or read in and then echo out our character input. Okay, again, very simple. Okay, we do it with Brad, B-R-A-D, Nels, N-E-L-S. You wonder why you'll see Nels so often. He's my brother. It's after Brad, it's the next thing that comes to mind. Okay, now, let's try something else. Smiley, who's my dog, is a sweet hound. Okay, anyone notice anything unusual there? No white space. So CN skips white space. You can't read white space with CN. CN uses white space as a delimiter. Also uses tabs as a delimiter, uses new lines as a delimiter. So just that warning that when you're reading character input with CN, it will skip white space. So for example, if I was trying to count the number of characters in the file and I felt that the space was a character, I couldn't write the program this way because it would skip all of the spaces. And if I wanted to get a hold of that space, I would use a command called getLine, which we will get to in another week or two. So don't worry about that right now. Just put that in the back of your head that if you're doing character input, that it will ignore white spaces. And you will be doing character input tomorrow in lab 2 because you're going to be given a treasure map, which consists of characters, and you're going to read the characters one at a time, and you'll need to check to see whether the characters represent ounces of gold or not, or nuggets of gold. So you will, in fact, be doing something similar to this, but you won't have to worry about white space because white space obviously won't be a gold nugget. So, questions about this? Okay. Just a couple other quick things. So, Dr. Planck loves the make command. Have you dealt with make before? Well, don't worry a whole lot about it now. Make is a command that is able, if you give it all the right commands, it will compile for you. Let's see. Well, it will perform automatic compilation. Basically, any .cpp files in a directory, it should try to compile them. Let's see if it does it. Nope. Yep, needed a make file. So you need a little bit more. Dr. Planck with his notes typically makes make files. So let's okay, so here is the make file that he is referring to. And you don't have to really understand it, but it's good for project management. You'll probably learn more about it either later in this course or when you get to 302. But here it's saying executables. These are all the executables we want to create in this directory. Then there's a series of commands. So I could say make, and then I could say good-eof-2, and it would execute this command G++ with these flags that had been set up here, and it would take this file as input, and if this file has changed, it automatically detects that the file has changed, and it does the recompilation. Don't worry too much about this. The big thing is, in many cases, Dr. Planck provides make files, and if you simply type make after you copy things from one of his directories, then it will compile everything. This often happens with his lab directories. You copy everything over, you type make, you get some rudimentary compilation going on. But it's a fairly advanced program, so we're not going to talk about how you create these make files, simply that the make command exists. Dr. Planck normally puts a make file in his lab directories, and if you just type make, things compile magically. Okay. I think I just want to point out a couple things. For those of you who are Mac users, you need to be careful when using cin with doubles, because for some reason, the Clang compiler, Clang is the compiler that Mac uses for C++, it interprets these letters as having special numeric meaning. So in fact, if you try to write a program that reads doubles, so here I'm reading into a double, printing it out, otherwise I'm clearing and reading it into a string, and then I print the string. Okay, pretty simple, right? Let's watch what happens on my Mac to it. I called the program Bard. So I enter Brad, and it prints out Rad, not Brad. And why is that? Because B has special meaning. Okay, it interprets B as a hexadecimal, and it eats it, thus leaving only RAD. How do we get around that? You use this flag during compilation. So it's saying use a standard library called libstandardC++. So if we compile now using that flag, and rerun, yeah. Really? Lib is deprecated, shows you. Move to libc++. Okay, let's try that. And then I'll change my notes. There we go. I'll change my notes. Okay. What? But then before, that worked. That's why I was using standard lib stdc++. Apparently.
That's GNU's library, but I don't think they ship it anymore because of licensing.
What a pain in the neck. So they're not going to. Okay, bottom line, you're going to have some problems with reading doubles when you have invalid input on your Macs. Okay? So just be aware of that. And I don't think we have an assignment involving the reading of doubles with invalid input, but should we do so, and you have a Mac, I would log on to the Hydra machines in order to do the compilations. Okay, because otherwise, so on the Hydra machines, we're using the GNU compiler, but on Macintoshes, it's using the so-called Clang compiler from Illinois. And as you can see, it doesn't work quite the way we would like. Okay, a couple other quick things. You'll note that when I wrote my program back here, actually I used cin, but if I had negated it and I tried to write it if not cin into N1, so here what I'm trying to say, if when I tried to read cin into N1 it failed, do something. Except that it will always return true. Okay? And the reason is cin apparently is, oh wait, I think it returns false. So the problem is it always negates cin and it will always return false because the not operator binds more tightly than the greater than operator. The solution is to put parentheses in front of around the read statement so the read statement gets performed first. Very easy mistake to make. So the problem here is that this operation gets performed first. And that's not what you want. So once you do that, the operation will always fail. You'll always go to the else branch. Okay, the other thing Dr. Planck wants to make sure that you remember is cin reads words and not lines. Okay, and the delimiter cin uses spaces, tabs, new line characters. If you want to read an entire line, you use getLine, which we will get to in a couple weeks. Questions about CN? Okay. Let's move on to output. And did you cover Cout and Cair in 102 or 130? In 102, but kind of hazy maybe?
We may not have covered Cair.
Okay. So remember that C++ uses what are called streams for input and output. And it defines 3 streams for you. The standard in stream, which goes to C, is read by Cn. The standard out stream, which is where normal output goes. And an error stream, which is where messages go, error messages go to. Now, normally, error messages go to the same place that, or printed in the same place that standard out messages are. So here, you are allowed to print to either the Cout stream or the Cair stream. You write to the Cair stream when you have an error. But when you compile and run the program, they both got written to the console, which is what normally happens. Normally, Cair goes to the console. Okay? You might be thinking, how do we separate these 2 streams so that we don't have our error messages mixed in with our normal output? Well, to do that, we have to introduce the notion of indirection. If we, on the command line, use a greater than symbol, it says, instead of printing standard out to the console, print it to this file instead. It's called a redirect operator. Redirects output to this file. So now if I run that program, okay, it writes the Cair message to the console, and it writes the normal output to output.txt. So now I've kind of separated the 2 streams. All error messages are going to the console, right here, and all normal statements are going into this file. What if I want also the error messages to go to a separate file? Well, then I put a 2 in front of my redirect operator because C++ numbers the streams. Cin is 0. I'm sorry, standard in is 0. Standard out is 1. And standard error, stderr, is stream 2. So the statement 2 greater than says redirect the error stream, standard error, to error.text. And now, if I look at the contents of error.text, I see that it has my error messages. Okay? So there are, in fact, 2 streams, standard out and standard error. Okay, you'll see them written like this. Cair prints to standard error, Cout prints to standard out. Normally, both of these are directed to the console. You can redirect them with the greater than sign. If you say greater than ampersand, it redirects both streams to the same file. And you can do the same with input. If you were to write back here with some integers, if I have my input.txt, 1020 Brad 50, and I run some integers, I can use less than, and now it says rather than taking standard input from the console, instead take it from this file named myinput.txt, which it didn't like too well. It's interesting. Oh, that's because I forgot to recompile it after a sec. It will work now. Always helps to recompile after you mess something up. So less than redirects standard in, greater than redirects your output. Okay. Questions? Okay. Printf. As I said, printf comes from C, and therefore you have to include a C library when you use it. C loves its abbreviations, so C standard IO stands for the C standard IO library. So just like IOstream is the one that gets you C in and C out, CSTDIO gets you printf. And printf works quite simply. If you just want to print a string, then that will print hello world. Normally we want to print the output of some variables. Now with cout automatically knows the types of variables. You don't have to specify the types of variables. Printf, you have to specify the types of the variables you're printing out. So here, let's make this a little bigger. I'm printing integers. I'm going from 0 up to 9, and I'm printing out I squared. And you can see that I'm saying I is %d, I squared is %d, I times 2 is %d, and then after the string I have I, j, and I times 2. So with a printf statement, what you do is the first argument to printf is a formatting string with quotes. And where you want to insert the values of variables, you use format specifiers. They start with the %sign. And after the formatting string, the remaining arguments are all the variables that you're going to print out. So this is, you may or may not like this just yet because you have to specify the types of the variables. But it gets a bit better once we want to get to whiffs of fields and left justification. It's going to be a bit more terse than cout. But first of all, any questions about this printf statement? Okay. So we might like to notice Dr. Planck says this looks a bit ugly, and we might like to print them in nice columns. So now we're going to use a width specification. So you'll notice he put a 2 right there to say that the width of the field should be at least 2 characters. The width of this field should be at least 3 characters. And the width of this field should be at least 2 characters. This is where it gets better than cout, where you would have to do a set W for each of them. Here you just put the number in front of the D, and it gives you the width. Now what happens, does anyone remember from 102, what happens if I try to print 104 and it's %2D?
It just expands past the 2.
Very good. It expands past it, so it doesn't truncate. It will always print the full string. But if instead I try, let's say instead I'm printing 5, it will put a space in front of the 5 to create a 2-character field. So it says it's a minimum of that width. But if the string is longer than that, C++ will print the entire string. So you see it's now lined up much nicer in columns. Okay? So the format specifiers that we have are the following. If you want to print an integer, you use either %d or %i. It doesn't matter. Both of them say that you're printing an int. If you want to print a double, then you are going to say %f. Actually, I think he's saying lf. I always thought, okay, we'll go with lf. I think it still works. Pardon?
Yeah, they're still equivalent because it's casted.
Yeah, I seem to remember that. I think technically that if you say f, it will cast it to a double. So LF stands for long float. In this course, we don't use floats, we use doubles for precision purposes. So always use doubles, don't use float. %f should work. Okay? Then, if you want to print out a string, it's %s. If you want to print a character, it's %c. Those are the big four. Okay? So those are the four you need to remember. Now, with floats, we often want to specify not just the width of the field, but the number of decimal digits. You do that with t.d, where t is the width of the field, d is the number of decimal digits. So down here, Dr. Planck is printing out pi, the value of e, and the value of natural log of 10. You'll notice he's printing them in a minimum of a field of 7 and saying there should be 5 decimal digits. How many digits does Dr. Planck think are going to be whole numbers here to the left of the decimal field? 1. Because the dot, the period, takes up one of the 7 characters. So in fact, Dr. Planck is anticipating that each of those 3 values will be a single digit, which he's right about, right? Pi is 3, e is 2, natural log of 10 is something like, I think, 3 something. So just so you know, it looks like there should be 2 digits in front of the period, but that's not true because the period takes up one of your characters in the field. So 7.5, long float, and you get your results. I was wrong about natural log. It's only 2.3. And he's saying, how did I know where those math functions were? They're in CMath. So you'll notice he included CMath up here. Okay. Now, so my claim, I agree with Dr. Planck. This is much more concise than having to write the similar thing. If I tried to do this in with cout. See what I'd have to do something like cout set W7. So I think set precision 2. It's probably enough at that point. Pi. That's a little more verbose than just saying percent 7.5 LF. Right? Okay.
And don't the manipulators like keep the state? Like they don't.
They do, but not for width, I think.
So
There's one, I'm a little rusty on cout. I think with precision, it remembers. Justification, it remembers. I don't think it remembers width. I think you have to always specify width, but not. Okay. Now, before we go on, anyone see any small problem with a character we might want to be able to print but can't right now? With printf, there might be a certain problem with printing a certain character. Pardon, I think I hear it. The percent sign, because if something starts with a percent sign, printf thinks it's a format specifier. That, well, let's try. So let's do print.cpp. Add two things. Let's print.cpp. That worked. Okay. I believe that a backslash would also work. No, interesting. Okay. So you need to put just 2 in a row will give you what you want. And if instead you want a check that. Yep. If we want quotes, then we use a backslash. Same as in cout. So that's to me a little annoying, but it is what it is. How do we get a backslash? Double backslash. So if you want a percent sign, double percent sign, you want a backslash, double backslash, you want a double quote, backslash, double quote. Okay. So questions about that? Okay. Last thing, I think. Yeah, I'll let you read up on chars, octo, and hexadecimal on your own. Clara, you'll need to go over how you can do character arithmetic. Okay. Yep. Okay. So I'll let you do that in the lab tomorrow. Okay. So let's say I want to print things out left justified. Remember, by default, everything prints out right justified. That's fine for numbers. That's typically wrong for strings. The way you get left justifications with printf, the minus sign. Very nice. Very compact. But, and this is a big but, printf is a C function. C does not have classes. C does not know about C++ strings. Therefore, %s doesn't work with C++ strings. Let's give that a try. String at name equals Brad. Let's print out Brad. Epic fail. So, lots of unreadable stuff. Cannot pass a non-POD object of type standard blah 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 string, aka basic string. Ooh, also known as. How about also known as string? How about something simple like string? No, nothing like that. So what it is trying to tell us is that it does not, printf does not recognize C++ style strings. It only recognizes C style strings, which we have not exactly talked about. Finally, it does say, did you mean to call the CString method? Yes, we did. CString will extract or return a C style string. So if you want to print out a C++ string, you give it the name of the C++ string, and then the .c_str function will return a C style string, making it very happy and printing out just fine. Okay, so just remember that, pain in the neck. It'd be really nice if C++ would change things so that it would recognize, printf would recognize C++ style strings, but it doesn't, so you have to do it that way. Okay, so in lab 1, we are fine with you using either cout or printf. After that, we'll be wanting to use printf. Okay, so I will see you all Thursday. Remember, no office hours today, but I will look at Piazza if you do have a question.